Hi there, I was watching a movie. Should I stop the movie or should I start this coding lesson? So many decisions. I know. Let's start the lesson. Welcome to Coding Adventures, everyone. Today we are talking about conditionals. So let's get started. Alright, so as I mentioned in the beginning, today we are talking about conditionals, which are basically the if else, this kind of statements that allow your program to branch on one path or the other based on a condition. So let's switch to the notebook and first understand exactly what these statements are about. Okay, so there are three types of ways in which you can basically mention conditions in JavaScript. And the first one, and I'll start to write it here, is this simple form. It's a simple if instruction that has a condition in between parentheses. And if this condition is met, a block of code is executed. That's it. And we start getting familiar with this block of code from the lesson with about for, right? So this condition is exactly like the one that we encountered when we did the for. For instance, maybe we can check if a number is less than a certain value. So if a is less than 10, then execute this block of instructions. Otherwise, this block is not executed at all. Isn't this interesting? Once we introduce if, we already can create really interesting programs that can take many decisions inside. Another form of conditions in JavaScript is when we have two blocks. We have two blocks of code, like that. So the first block here, and the second block here. And we can decide if a condition is met to execute the first one, otherwise execute the second one. So this form of if, it's as in this example. We put if, we put the condition here, same as before actually, right? And then we have a special keyword called else. And once we do this, basically if the condition is met, the first block is executed. Else or otherwise, the second block is executed, right? So this is very powerful. It enables us to do even more complicated decisions. But this is not all. We have another form in which we can basically take a ladder of decisions. And in this form, we can check initially for a condition. And if this condition is met, we can execute a block of instructions. Else, if, and then we can check basically if another condition is met, we can execute other block. Else, if another condition is met, we can execute another block, and we can continue like that, like forever. And then at the end, we can finally put an else. When none of the above conditions are met, the last block is executed. Sounds interesting, right? So what better way to practice this than to jump on the computer, open the code editor, and do a few small examples. Okay, so let's get started. Let me put my notebook away and jump here on my computer. And I'll open the code editor. Boom! Here it is. And for the beginning, let's do some simple steps, baby steps into conditions, right? So let's declare a variable. Perhaps we should name it this variable a, like in the example on the paper. And let's choose a value for this variable. And let's now write a simple if statement, a simple condition here. Perhaps we should check if this number is positive, right? Which, of course it is, because we can see it, right? But in a complex program, we may not see it at that moment, and we let the computer take the decision. But anyway, let's check if this number is positive. So to be positive, a number should be greater than 0. And now we put a code block here, like we said. So we expect if this condition is met, this code block to be executed. So let's put here inside something. Number is positive. All right. So what should we expect if we run this program? We should expect saying here number is positive. But what if the number is not positive? Let's try it. Let's say we have a -2. Nothing. Well, it's normal. This block didn't even get executed. And why didn't get executed? Well, because the condition is not met. A is less than 0, so basically we are not entering this block. We are jumping all over. The next line is here, basically. And here we don't have nothing, so basically nothing is displayed. It's fun, right? And simple in the same time. Let's play with the other forms of if. Let's try to introduce here a little bit of else and eventually maybe even a little bit of else if, right? So maybe we should say here else. So if it's not positive, should be negative, right? We can write here println number is negative. And then here at the end we can just put a println thank you for using our number tester program. Perhaps somebody makes this program and gives us to test it and we are using it and they are happy we use it. So let's see. What should I expect? First of all, if we inspect the program, the number is negative. And if it's negative, basically the first block should not be executed. Then we expect the second one to be executed. So we should see this text. And then we should see this statement. This statement is executed regardless of the if. It's just a single statement inside the program. So let's run it. All right, number is negative. Thank you for using our program. Let's put back the number 10. Number is positive. So works, right? It's correct. What about if we put 0 here? Number is negative. Really? 0 is not a negative number. I think it's the only number that is not positive or negative. So let's check for that. Perhaps we can put the first condition, an if it's 0, or we can put it here in the middle as well. We can say else if a equal 0, and notice the way I wrote equal. A triple sign equal. We'll get in a second to this one. Print, and then we can say number is 0. Let's run it. Number is 0, works as expected. Let's try a negative 10. Number is negative. Let's try 10. Number is positive. All right. So see, ifs are pretty simple. As a matter of fact, they are so common nowadays that even the consumer kind of electronics, they use the if this then that rules. And this is all about this kind of if else statements. If this is condition is true, then do this block. Else or otherwise do this block, and so on and so forth. So very simple statements, but very powerful in the same way. We can achieve pretty complex pretty complex logic here. Basically, you'll believe that the machine is thinking, right? So it's the is machine learning for kids or for beginners, basically. It's of course it's not machine learning, but program starts to become more intelligent with the ability of these conditions that makes the program taking decisions based on different values of the variables. All right, so so we saw this form again in the past, actually, when we said over here a is greater than 0. We also saw it in the other order, but what is this form here? Why we say when we want to compare a, if a is equal to 0, why we use this weird form, triple weak equal? Why not 1 equal is enough? No, it's not enough, I'm telling you for sure, but why not? So let's understand this one. Let's switch really quick now to the notebook and test basically this, and basically discuss about operators. So let me write here operators. Oh, you're not seeing? All right. Now it's better, right? So if you give me just 1 second, just a second, just to put here a little bit more light on the paper, and we should be good. All right, so let's continue now. So we see here the operators, and well, they are mathematical operators, first of all. Perhaps we should briefly mention those, like arithmetic operators, and then there are these, so these operators for arithmetics, we already saw them. They are the plus operator, they're the, minus, multiplications, division, and there are others. We're gonna, maybe touch on a few others, or at least one today. And then, but more importantly, we are interested in comparison operators. So what are operators? It's nothing else than a fancy name for these signs that basically compare a variable with a number or a variable with another variable. So when we want to compare these kind of things, we say that, okay, we're gonna need a comparison operator. And the one that we saw until now, basically less than, greater than, I think we saw this one plenty of times in the previous lessons, less than equal, and we say that we have to write it as is, as it appears here, no spaces in between, exactly like that, greater or equal than. And I'm gonna just put it underneath, because in math you may write this one like that, or you may write this one like that, right? So it's a less or equal than 10, or the same here, a greater or equal than 10. But since we don't have this symbol on the keyboard, actually when we input this operator, we input it using two different characters squished together. All right. And now for the final operator here, the surprised one is, ta-da! So what is this operator basically? It's the equality operator. It checks if two numbers are equal. But the question is, and if we look again, why do we need triple equals? Why one equal is not enough? Or at least two equals? Why do we have to use three equals? Well, in JavaScript, all these symbols are actually used, and the equality operator, actually this one is not equality operator, this is an assignment. If you remember before, so when we declare a variable, we use it in forms such as let a equal 2, which means it puts the value 2 inside a. It doesn't compare a with 2, it just puts it there. So basically this one is not good. What about why not use 2 equals? Well, this is okay. It's actually used to compare if, for instance, a number is equal with a value. For instance, is a equal with 2? We can use this operator. That's fine. That's not problem. But the problem with it is that it's a little bit obsolete. It has some small side effects. Therefore, in newer JavaScript specification has been replaced with a newer operator, which is basically triple equal, which does a little bit more precise check. And we don't want to go into too many details about the difference between equal and triple equal at this stage of the game. We'll discuss about this one in the future. For now, try to use triple equal as much as possible, but if you use double equal, it's also fine. But never, don't use a single equal inside if you want to take a decision when you are comparing two numbers, okay? That's an assignment, and your program will not work. Actually, you know what? We have a program in front of us. So let's go back here. Let's put 0. With 0 is working. Let's try double equal here. Is working again. In this case, see, the editor here gives us a hint. It's better to use triple equal, but I'm telling you, in very rare circumstances, you need triple equal. But, you know, just to avoid the issues, use it whenever you want. But let's now try to put a single equal. This is just a pure error. At this moment, even says here, assignment in conditional expression. It means that we are not taking a decision here. We are just assigning a variable to 0. And basically, see, the program is totally taking a different decision. It goes on this particular branch, in this code block. So this is a common mistake that beginners are making. Use single equal when you are assigning variables, and we did plenty of examples until now with that one. And always use triple equal or double equal is fine as well when you are doing comparisons, and you should be in good shape. All right. See, it's not that difficult. So all right, let's play a little. Too much theory, it's not good. So let's practice more on the computer. Let me save this one really quick. So this one is simple comparisons. And I can put it even on the chat for you. Remember, if you are now live on the chat and if you have a question, just put it there on the chat. All right, the program is on the chat, and let me click this program and play a little bit more before we going into more advanced examples. Also a little bit more with these comparisons, right? So we tested before if a is greater than, let's do some constants here, simple constants. If 2 is greater than 1, do you think this is valid? Do you think this program will run? Let's put here yes. Or is running. Yes, of course it's running. And because 2 is always greater than 1. But if we try to put here, if is 2 less than 1, it's not running, we don't see anything. So anyway, this is not a very practical way of comparing. You don't compare two constants. There's no way in doing that. You already know the answer. You're comparing a variable with a number or two variables between themselves and then take a decision. All right? But I just wanted to show it to you. Yeah, let's do one more exercise. And you know, you like to do shopping, right? So pretty sure you saw those rating systems when people rate a product and then the online shopping system shows a lot of stars, and if it's, you know, a really great product, you get 5 stars, and if it's a poor product, you get 1 star, and so on and so forth, right? So let's try to implement one of those here, right? Maybe we'll do our next Amazon in the future. Who knows? This is the beginning of the next best big online shopping. Let's get started. So let's have a variable. Everything begins with a great variable. We'll name it rating. And the rating is 5. And now let's take some decisions based on this variable value. So we'll say if rating equal 5, again, notice rating, I said is 5 initially, right? This is an assignment. Now we are comparing with 5. If rating is 5, then we're gonna print, well, at this moment we don't draw stars. Those are, we'll give it to the graphical design folks to draw the stars. We're gonna just print here, excellent. All right, let's take other decisions. See, we can take a decision now based on a range. Maybe if rating is, yeah, that's true, based on a range. I think this is the right way to do. Oh, and thank you, Success Paths put a comment in the chat. Thank you. Thank you for watching. So how can we check perhaps if the rating is between two values? Maybe if it's between 4 and 5, then we can say the rating is good, right? I mean, it's a good rating. Look how I'm gonna do it. We'll say if rating, obviously if it's greater than 4, means a good rating, but we should say between 4 and 5. We don't have an operator to verify between, we don't have the between operator to verify between two numbers, but we can always say if it's greater than the lower number and less than the bigger number, then it's the same, right? So the way we say and, we put these weird symbols here. This means and, but and is not working in JavaScript. I just leave it for a second and replace it back. And rating less than 5. So this means and, but we cannot put and. Some other programming languages use a more English-friendly words. JavaScript designers used to put this weird symbol, which are two ampersand symbols, one after the other. No space in between. Don't put space. Just one after the other. And don't put just one. You know, when I'm saying put two, please. It's very, very important. Oh, else if here. What was doing? So in this case, we can print, well, the product is good, right? So let's repeat the logic. So if it's basically rating greater than 3 and rating is less than 4, so basically the other interval between 3 and 4, we can print it's probably an average product. Else, you know, you can check multiple ranges, or we can just go directly and draw a conclusion here. Else, if it's below 3, basically, which is the other interval possible remaining, logically possible remaining, we can just print, you know, below average. Let's try our program here. Boom! We have an excellent product. Let's play with the numbers, and we can put here decimal numbers like 4.5, right? Because numbers in JavaScript, they are not just integer or natural numbers, they are actually real numbers. So you can put with decimal, and decimal, as we said, you put a dot. Even if you are in a country that using different regional settings and use a comma, just put a dot in, use the American notation and put a dot. Okay, so we can see the rating is good. Let's check for the other ones. Perhaps a 3.5, it's average. And if somebody just gives a rating of 1, well, below average. Our program is working. And we also introduce a new concept here, which is basically this notation, which is a logical expression, is basically an operator, an AND operator, that allowed us to combine these two other expressions together. So let me save this really quickly. Rating products. And again, please expect to be on the chat. All right, so the program is now on the chat, and you know, since maybe we can discuss a little bit about these expressions, or we can do, you know what, let me do 2 more exercises, and we're gonna just switch back to the drawing board and discuss about these operators a little bit more in depth. Sounds good? Okay, let's get started. All right, I'm starting a new program, and I'm now linking into the previous lesson about for, and I was just thinking maybe we should have done this before the other one, but it's working in this way equally great as well. Triple equal great. So let's do quickly a for loop. For I equals 0, I less than 10, I plus plus, right? And print I. Our first example with a for loop. We did plenty others, but let's return back to the basics. Let's run this example, and as expected, it displays the number from 0 to 9 because that's how we designed the for loop. And if we want to display more numbers or less numbers, we can just change this number in the comparison. And wait! Look, this is a comparison. Now starts to make more sense, right? So basically here you can put any comparison you want. Like the ones that we are learning today about the if statement, but you know, those are pretty advanced use cases of for, and we just said let's focus on 5 use cases, the one that we discussed in the previous lesson. So anyway, coming back to the example, so we are iterating I from 0 to 9 basically, and we are displaying it. And if you want to display less values, we can basically, you know, go here and change the number. But there's another way. And that way is, of course, using an if, because we are at the if statement lesson today. So look, let's display the number, and then let's check the number with a certain value here, saying if I equal to 5, or we can say greater or equal, however we prefer. Equal is fine, because it just goes by 1. We can just put this keyword here, break. And just to keep the consistency, let's put the break inside the block. We said that if we have with certain instruction, we didn't mention about the if, but when we discussed for, we said if we have just one instruction, we can put it just like that. But it's always best to just to place a block, just not to forget something, or in case you want to add multiple instructions. So let's analyze a little bit the program, and it's pretty intuitive as we can see it. If I equal 5 is breaking out of what? Well, actually out of 4. Break is applicable to 4. So in the moment the execution will encounter a break keyword inside the for loop, it will just break out of 4 and execution will continue immediately on the next line. Here we don't have anything. So let's see how the result. Boom, right? So we stop at 5. 5 is the last number printed. And then because we are checking, is this 5? Yes, break. So just amend your page about the 4, and now you have one more way to go out of 4s. Now, of course, this is not a very practical example, so why would we want to do that? We can just basically change here and put a 5 instead, or a 6. But believe me, there are some other good reasons. Maybe we are not checking for 4 here, but maybe we are in a very busy loop doing some processing, and we check if we click the Q key on the keyboard, maybe we should quit, right? So in the moment we press Q, we check here inside, you know, the variable that contains the character press. If this equal Q, then break, and boom, we are breaking out of 4. So, or something like that. So there are some applications around that. So this is a simple for break. Pretty easy one. We'll get the chance to play more with this one in the future. So let's do one more exercise. Again, I still remember we have to go back to the drawing board and discuss about those fancy ampersand characters. But before then, let's do one more exercise. And I'll introduce also a new concept in this one. But anyway, let's see if we can do it. It's also about for. So let's use a for loop and display the even numbers. Okay, and we have an example. We did this already, right? So today I'll do it in a different way, and then open the other one, we'll compare them together. So let's see how we'll do it. So if you remember the last exercise, we are just iterating to the numbers from, let's say, from 0 to 10, and we use a step of 2. Therefore, we're stepping and we're matching directly the even numbers, right? We're counting 0, 2, 4, 6. So today we are doing differently. We are iterating from 0, let's say less than 10, and we'll iterate by 1, right? So if we iterate by 1, obviously if we just put here a println of I, will display basically all the numbers, not only the even ones. But we can use a if inside here and display only if it's even, right? And if it's not even, we'll not display it. And therefore we'll continue to the next number, and another verification will be made, and so on and so forth. So let's use an if statement here. And the way we are verifying if a number is even is we're gonna use this operator basically. If I, if reminder of the division of I with 2 is 0, let's print the number. See, even numbers. Let's go up to 100. Even numbers, no problems. But what is this operator, you may ask? Well, again, this operator is not division. Division would be like that. If I divided by 2 equals 0. We are not saying that. We are saying we are dividing I by 2, and that operand returns the remainder. So it's not doing a division, a decimal division, and returns maybe 3.5. Instead, for instance, if we are dividing 7 by 2, you know, in a typical decimal division, this will be 3.5. But when we are dividing using this operator, basically this will return 1. So why 1? Because the result of this one will be 6, remainder 1. Meaning 6 times 2 is 7, and the remainder is 1. And you learned about this one in probably before learning about decimal division, but so much time passed since then. Most probably most of us forgot about all these tricks from the elementary school. So yeah, so this is actually, you know what? This is the other arithmetic operator that I want to add to that table. And now I'm gonna switch to the table. Let me just use this here, even numbers with remainder. I'm gonna save it, place it on the chat, and then I'm gonna switch to the drawing board. All right, so let me make some space here, and I'm gonna switch to the drawing board in a second, and just add, oh, we're on this page, great. Let's add also this operand here, and what we said, this one is returns as the remainder of division. Is less common operator. Even in JavaScript, you are not using as much as the other ones. So basically, and we put there 7, when you use 7, for instance, %2, this one should return 1, basically, right? And we know the other operators are from math. Well, right. So that I'm glad we just amended this page here. And now let's discuss a little bit about Boolean values and basically the AND operators that we saw before. So what are these AND operators? We said this one is AND. And there is another operator, of course, since we said it's AND, obviously we may hint that there's a one for OR, and actually there is. This is 2 pipes, right? And I'm gonna put here another one. This is for NOT, which is just an exclamation mark, and we're gonna use them in a second. So these operators are used like we saw in that particular example, but before then, let's talk a little bit about Boolean values, right? So what is a Boolean value? It's a different type of data. Until now we encounter, probably this is the third type that we encounter numbers like 2, 3.5, 100, you know, -10, all these are numbers. And we used to assign numbers to variable, to use them in comparisons, to pass them as arguments. Remember, always middle of the canvas is 300, 400, use this kind of numbers a lot. And then we encounter strings, and when we say we're gonna place them between comments, and if the function expects a string, we should put it as a string, right? So hello, your name between quotes, things like that. Or, you know, when we display even today some messages. And now there's the third type of operator, which is a Boolean operator, which has only 2 values. It's basically, it is or it is not. It's on or off. The light bulb is on or the light bulb is off. On, off type, yes or no type values. But in here, we are just having a special name for this one. It's true. Actually, let me write it to smaller case, because that's how JavaScript is writing them. And false. So these kind of values are Boolean values. I'm gonna put here. And this one were string values, right? Okay, so bear with me a second. So each time when we wrote a less than, let's say, 10, basically this expression, it's evaluated to either true or false, to one of these values. All right, so this is really important. All expressions that use these comparison operators, they are evaluated as to a Boolean value. The final result is a Boolean value, therefore it is either true or false. All right, And now, going back to these logical operators, what this allows us is to combine different Boolean expressions into even a bigger one. And the result should be also a Boolean one. So it allows us to say a less than 10, or maybe even different variable, b greater than 5. This is a Boolean expression at this moment, and it's evaluated accordingly. So for instance, if this one is true, let's say a is less than 10, and this one is true, what is the answer, right? Because at the end of the day, we say here an if. So basically the entire expression now has to be evaluated to either true or false, because the entire expression here, it's a Boolean expression. And actually, to better understand this, I'm gonna switch back to the computer, and let's play with this a little bit more. So let's say let a equal 5. We'll just take exactly the same number like that we put on the paper, and b equal 10. And we said if a less than 10 or b greater than 5. And again, this one, there are two pipe symbols. They are found on the keyboard. You should find them. I can show you my keyboard, but if you're using an international keyboard, it should be in different location. So, but make sure, exactly like with the and, it's they should be basically typed with no space. So let's put here a println. Guess. What do you think the answer would be? This one? Well, guess. This is just a text, right? So if this text is displayed, basically this one it's evaluated to true, meaning that this expression is true. It's the a is less than 10, is less than 10 obviously, and b is greater than 5. And we put in between or symbol. If we put and, let's put here true. If we put and, also is true, right? So what's the difference? Why put and or? Well, the difference is that in this particular case, both of these needs to be true. If a is less than 10 and b is equal than 5, then only then, when both are true, it goes inside here. If one of them is false, perhaps b is not greater than 5, then we'll not see that text. On the other hand, if we use an or operator here, either one of them needs to be true. So right now it's true. All right, so they're pretty logical in a sense, but let's get a little bit more mathematical on these expressions. And just to complete a little bit the picture here, and then we'll get into the exercises. All right, so basically what I'm gonna do, I'm gonna show a little bit more about these operators, drawing them in some tables that are called truth tables. Right? And truth tables, let's say the first expression here. Let's take two expressions actually. The first one, let's say it's evaluated to true, and the second one is evaluated to true. What will be the AND operation? And then we have all the other values. The first one is true, and the other one is false. The first one is false, the other one is true, and then is false, false. What will be the AND? And then we can do the same, or in the same table actually, we can do the same for the OR. So again, this is AND, and this is OR. All right, so AND, both of them must be true. So there is only one case when this expression is evaluated to true. And as for the OR, can be either one. So basically we'll have multiple ones in which they are evaluated to true. So we have true here, true here, true here. So we have here true, true, and true. Right? So this is a little bit mathematical, and actually, you know what? You may not use this one a lot initially, but perhaps a more practical example should do it, right? So what better other practical example we should do than work with some canvas numbers? Do you remember our canvas? It has 800 by 600 resolution. So we know already that we know that it has 800 by 600, right? So let's say we have 2 points, x that is 300 and y 400 and y that is 300. And perhaps we should draw a small circle on x and y and a certain radius of 10 pixels, right? All right, the circle is here. Let's display a message if this circle is on the canvas or not, based on these coordinates. So supposingly we come back and change here the coordinates. So we can say something like that. How can we know if this point is on canvas? Obviously we can check if x is greater or equal than 0. So basically imagine this is the entire canvas. If x is greater or equal than 0 and x is less than 800, we check on all the x values, right? And then we can send, and y is greater or equal than 0 and y is less than 600. And as you can see, I put not only one but multiple expressions separated with and symbols. And then we can put here println inside canvas. And it's obviously inside the canvas, but let's grow a little bit. Maybe x become you know, we have maybe perhaps we're making a game and the character goes outside the screen, right? So let's see if we still see this message. We don't see the message, right? So but let's bring it back, and maybe this guy, it goes out minus 300. Also we don't see the message, right? So this is a very complex expression. And just to show you that this one is evaluated to true, what we can do something like this. Also, we can take it in a certain variable. This is basically an expression. So I'm gonna cut it from here, and I can go here and declare a variable inside canvas. And inside canvas has this value. Perhaps I should put it inside parentheses just to spot it a little bit easier. So, and then I can use this value here. If it's inside canvas, the code is now it's easier to read, right? Supposing that basically, well, we know that this is correct. Further on inside our program, we can check. If it's inside canvas, we print inside canvas, right? It's inside canvas. But let's place also here a println and actually display this variable. It's true. Because it's a boolean expression, it's always evaluated to one of these values, either true or false. All right, and of course if we go outside of the canvas, we see false and we don't see the other message here. All right, so a pretty simple example now is with coordinates. I think this one makes more sense than some abstract A, B numbers, right? So yeah, and actually it's pretty useful when we're gonna draw games. We're gonna make sure the characters doesn't go outside of the screen. So this is also pretty important. Okay, let's do one more exercise now. Should we save it? Should we not? Another decision. Not. Oh, about that not operator. I put a not operator. Let's say we have an expression. Let me get back. Inside canvas, right? Let me just remove this one. We see the circle. Actually, not remove it. Leave it like that. So it's working like before, right? What about if we want to check if something is outside of the canvas? Well, that thing we can check it. We define a variable. And we can start checking again these numbers. If x is greater than 800, or well, actually we can write it this time like that. If x is greater than 800, or x is less than 0, or if y is greater than 600, or greater or equal, I think here, or y is less than 0, then this means it's outside of the canvas. And let's actually let's print these ones, and these ones should be totally opposite, right? So the first one says true, the second one says false, because the first one is inside canvas, outside canvas is false. And we can put here a, oops. Maybe I should put here just to see inside some labels in front of this. Outside. Inside true, outside false, right? It was normal. Notice that I use or symbols here because if it's outside, if you know any of these coordinates goes outside, it means the point goes outside. But there's another way of calculating outside canvas. Supposing that we have inside canvas as a variable, we can say outside canvas is not inside canvas, which is the opposite of that. So basically, if inside canvas is true, outside canvas will become false. And if I run it, yes, as you can see, it's the same result here. So perhaps we should persist this program here. So logical coordinates. It's a very logical name for these expressions, and I'm gonna put it in the chat. All right, so now we are in good shape. We saved it. Let's do really quickly another exercise. All this theory and explanations are sometimes boring, and it's best to just practice our code. Always practice, remember that. So let's do a mathematical program this time. Let's see if a number is prime. Okay, so what means a prime number? Well, let's see what Wikipedia says. Prime number, Wikipedia. A prime number is a natural number greater than 1 that is not a product of two smaller numbers than smaller natural numbers. All right. In other words, a prime number is a number that is divisible only by itself and 1. So it's not divisible by 2, by 3, by any other numbers smaller than itself. Of course, 2 is the only even number that is also divisible by 2, but all the others are usually, they are actually odd numbers, not even numbers, because even numbers are divisible by 2. So we can, let's make a program to decide if a number, and we'll pick a number, 100. Obviously, this is not a prime number, but let's check it. And we want to see if this is basically a prime number. Let's see. Is prime number. So we're gonna use this kind of algorithm. We're gonna loop through all the numbers from basically 2 upwards and see if this number is divisible by that number. And if it's divisible by that number, it means that is not prime. If it's not, then it means it's prime, right? So let's start. So we start with an I from 2. I'll just write the program first in a very simple form, and then we'll try to optimize it a little bit. So it's less than 100, I++, right? If and we're gonna use the reminder here. If it's reminder when we divide this number by I is 0, so means it's basically divisible by that number, well, then it's not prime, right? We can put like that. ln is not prime. So let's run it. We see a lot of is not prime, but we don't have to check all the numbers, and now we know. If it's not prime, we just break out of 4 when we encounter the first situation. So it's not prime. Right, so let's pick another number, 17. Okay, oh, see if 17 is not prime. 3 is not prime. Why is that? Do you know? All right. All right. we go up to the number, not 100. I was thinking about 100. Okay, so this is not prime. So this is one way of doing it. Let's actually, you know what? Let's choose a boolean variable here saying is prime. And this variable has initial value of true. And since true and false are actually values, we can assign them to variables. So we assume that the number is prime, right? We just say it here. And inside the for, what we can say, if it's divisible with the number, we can say is prime equal false. We say is not prime. And we break out of for, which means the execution will jump at the end. And here we can print something like this. We can say if is prime, we can say n is prime, else is not prime. All right, let's try it. 17 is prime, 170 is not prime. All right, so looks pretty correct. We made use of a for. Again, we are iterating through all the numbers up to the number itself here. And then we are dividing those numbers with these numbers. And then we are checking if it's prime. Let's check another number, 2. 2 is prime. All right. Do we know why 2 is prime? I let this... so we are starting at 2 here, right? So if n we divide it by 2 is prime, what value does it have? Let's run it again. Because we are going less than the number itself. That's why we are not going up to 2 here. And here this loop goes from 2 actually to 1. It's not even going inside the loop. So 2 is basically prime. And if we'll check with 4, 4 is not prime, 3 is prime. All right. So in this particular loop, when we put 2 here again, the loop will start at 2, but n here it's less than 2. If we go less or equal than 2, we'll obtain a weird answer because we'll divide 2 by 2 and we'll say it's not prime. So let's leave it like that. Okay, another way we can check for this special condition, we can put here a check. We can say if n equal to 2, then basically the number means that it is prime and we don't have to do all the other calculations because we know that 2 is a special condition here. All right, there is another optimization that we can do here. We don't have to check all the numbers up to n. Actually, you know, we should stop somewhere in the middle. But where in the middle? Let's choose some examples here. Basically, let's choose 81, right? 81, if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, then comes 10, 11. So let's say we pick 81 there, right? Actually, we should stop in the middle at square root of 81. And the reason being, for instance, square root of 81 is 9, right? So, which means that 9 times 9 equal 81. Any other number after square root in this series, like 10, will for sure be greater than 81. So there is no need to check for numbers greater than square root of that number. And basically that the way we are checking square root is using this function sqrt, which is basically it's the same as the one that we used yesterday, sine. If you remember when we discussed sine yesterday, we wrote sine of an angle, maybe perhaps 30, and we took that value in a variable like that. In the same way, we can take the value of an square root of a number in a variable using the sqrt function. All right. Now, sqrt, again, for the new viewers on this stream, it's specific to CodeGuppy. It's coming actually from the P5.js library. It's a wonderful library. It provides a little bit of a training wheels for beginners. There is another form actually in plain JavaScript to obtain the square root. We're going to touch about that one, but that one will require a little bit more understanding of other concepts such as objects and so on. So that's why we are using this simple form here. All right, so this is a pretty simple algorithm for a prime number, and if you want to optimize it even further, I'll let this task to you. So for this prime number, I'm gonna put now the program on the chat. Feel free to take it, optimize it, and play with it. And since we are in the math domain here, I hope you'll not be upset with me doing just these math questions. Maybe you had a math class today and we are doing math again. You should be infuriated. But I promise, one more math problem and then we're gonna do some fun drawings, okay? So bear with me. I was thinking about finding the results of equation of second degree, which is the quadratic equation. And sounds pretty complicated, but it's not. We're gonna use again Wikipedia. Let's put here quadratic equation. We're preparing the terrain here. I'm saving the program. And actually, you know what? I'm gonna share it with you from the beginning, and from time to time I'm gonna save it. But on your side, if you are watching right now, you can reload as I'm saving and, you know, run the partial result. So quadratic equation. All right, the link is on the chat. If you refresh it right now, you should get an empty page. Let's first understand what that is. Quadratic or Wikipedia quadratic equation. All right, this one. Okay, so it's the equation of second degree is this one. Ax squared plus bx plus c equals 0. And we can see here the formula for this one. Actually, this is just a partial case for this formula. But what we have to do, we'll create a program that, let's say, we have the ABC coefficients here, these known numbers, and we have to find out the roots, basically the roots of this equation. And as you can see also here, because it's a second degree, it will have two roots, all right? So let's have some maybe constants. Let's use const. Let's make use of the word const, because we don't have to change them during the lifetime of the program. Let's say A is 2, let's pick B is 3, and let's pick C equal -5. Okay, so we have these numbers, and now what we have to find out is X, which is basically two solutions, so X1 and X2, and we're gonna use if statements. How come if statements? This is a simple formula here. Well, you'll see in a second. So let's start with this simple formula. You can see here there is a square root, and square root actually is defined for positive numbers. Is not for negative numbers. This will have no meaning. Therefore, the expression below must be positive. If it's negative, it's basically a different story here. So see, already we have to make use of an if to check for this one. Also this one, actually let's scroll down here. Maybe they explain this better. Let's see. Yep. That form there, oops, I lost the page. That form there is called the discriminant or delta. And basically it says here, if the delta is positive, then we can take the square root out of delta. If the delta or discriminant is 0, we do this operation, which is basically a reduced case of this one, because square root of 0 is 0. So we do this one. And if the discriminant is negative, there are no real roots of the equation, right? So as you can see already, there is an if-else algorithm here, perhaps even an else-if algorithm. So, but we'll do it baby steps, and we'll add the else branches later on. So let's do it baby steps here. Let's start by calculating the delta here, the discriminant, b squared minus 4ac. Okay, so let's have here, maybe I'll use variable from now, delta is b squared. We'll write b squared like that, and then here minus 4ac. I forgot already the formula. And now we'll take a decision based on delta. We'll check if delta is greater than 0, we should do what they say, basically according to the math. And there is a, you study in school how to reach to this, these formulas. But according to the math, we have two results here, minus b square root of delta over 2a. So basically, let's define two variable x1, which is minus b, plus sqrt. We are using this sqrt function, see that the one that we used before, of delta over. So here it's over the entire expression over 2a. So we'll just put this inside the parentheses here. Let me leave some white space over, and I'll put the second one in parentheses just to be clear, like that, right? And the second one will be the same basically, only we just subtract here minus b minus square root of delta over 2a. Now, square root is a pretty fast function, but each time we have this kind of expression that are duplicated, we can take them in a separate variable just to avoid recalculation. So maybe sqrt delta, we can have it like that. Again, extracting square root of delta is a pretty fast operations, but if we are just, and should not matter if we are doing it twice, but if we do like this, we are just doing once, so it's a little bit faster, and then we just reuse the result here, right? So this is x2. So we have the x1 and x2, and we can print them directly. So we can print x1 equal x1, let's print on the other line, x2 equal x2, right? And I'll save it, I'll run it, I already have some results. So apparently the numbers that I put here made the algorithm, made actually, you know what, let's check them. How can I know that we are that they are correct? We're gonna go to all from alpha. So this one, and 2, 3 minus 5, 2x squared, 2, 3 plus 3x minus 5 equals 0. So this is our equation. Let's see what does it says. It says minus 5 over 2, which is basically minus 2.5 and 1. Yep, it is correct. All right, so apparently we are on the right branch here, and our program worked from the first try. But what if, let me play a little bit with the number here. Perhaps we have 13 here. Okay, let me let me put another number here, 5. All right, we don't have anything here, so it means that the program didn't went on this branch here. Basically delta is negative, so let's read on. If we don't handle the other cases, our program, as you can see, will produce unexpected results, or may even crash at runtime, during runtime. All right, so delta is negative. These are basically the results. Well, and we can display them in the same way. You know, we can say here else. You know, for simplicity, just not to do again this calculation and not lose time, we'll just say println equation has complex roots. And you know, I leave to you as an exercise to write this a similar kind of code as here in this one, and display it with an I, which is the imaginary number. So equation has complex roots. Works fine. Let's see about this case here. If the discriminant is 0, well, we can handle that one as well, although it should be handled by this case because we extract a square root of 0. But you know what? Nevertheless, let's handle it. Else if delta equals 0. It gives us another chance to play with else ifs, right? They are fun. So perhaps we should say here something nice. Println, we can say equation has 2 real roots. Equation has 2 complex roots, and here basically its equation has just one root, and is basically given by that formula minus b over 2a. So it's basically println. Actually, x1 is equal to x2 in this particular case, is equal with minus b over 2 times a. All right, And this time I put the expression, as you can see inside here. I don't have to take it in a variable. Refer to the lesson about variables about this one. I'll run it to complex roots. We are still on the other branch, but of course we can play with these numbers. I don't have any set of numbers prepared, so I hope I did it right. I didn't reach this branch here. Perhaps if you tell me on the chat here some numbers to try, we can reach that branch really quickly here. Otherwise we have to Google more. Anybody knows what number should I pick to go on this branch here and check it really quick? Let me put a timer, give you 10 seconds. Put it in the chat. Okay, no answer in the chat. No problem. We can check it other time. But still, I want to show you something here. We are not done. What if somebody, let's suppose this is we create this a fancy new UI for this one, and somebody types in the number, enter coefficients, we type in ABC, and sometimes somebody goes and types a 0 there. Boom! It says that has 2 real roots, but these are just garbage here. Well, at least looks like garbage to us. And you know, a good program should check also for these edge cases, right? So if A is 0, actually the equation is no longer a second degree equation. It's not a quadratic equation anymore, because if A is 0, it remains just bx plus c equals 0. So what we can do here, even before calculating delta, because that's specific to quadratic equation, we can check here. If A equals 0, we can say println single second degree first degree equation, and we can solve it that one as well, because remain bx plus c equals 0, and we can find x by, it's minus c over b. Of course we have to check if b is 0, because if b is 0, it's yeah, maybe we'll solve it anyway. Else, and now looks what's happening. This will become a total mess, but we have to do it. I'll take the entire program here and place it inside the else statement. And I'm gonna ident it 1. I always encourage you to ident your code. Let me zoom out just to see it better. Yeah, this zoom level fits on the screen entirely, but still there are ifs in ifs and else in else. This is perfect valid syntax. Let me run it. It says first degree equation here. It's a perfect valid program. It becomes a little bit difficult to read, but with what we learned until now, we have no choice. Later on, we're gonna see other elements that will allow us to modularize this a little bit and make it a little bit better to read. But for now, the program still runs, and if we want to practice even more ifs, we get even more chance here, because basically here we can have x equal minus b over c. I think it's minus c over b. It's minus c over b, and we can println x equal, and we'll display x. Let's run it. And is this number, let's write, is this minus 2.1, but we have again to check for b, because what if b is 0? So first of all, it will say here minus infinity, of course, because we are doing division by 0, we have to check if b is 0 here, and then basically what will be the meaning of this equation? If a is 0 and b is 0, it will mean a constant equal to 0. So either has infinite solution, or if c is 0, or otherwise it's non-deterministic, because 3 is not equal to 0. So plenty of chances to check here. I'll not continue, because to do, I'll put here a to do, check also if b is 0. And I'm gonna save it. So I'll give this as an exercise to you. So complete this one, and basically you should have a pretty robust program that checks for all these combinations using if statements. All right, so so much math for today. Oh, I promised that I'm gonna show you the program where we print the even numbers. So this was the even numbers that we printed today, and I think yesterday or 2 days ago we printed the other one. Anyway, you'll find it in one of these programs, so let's keep it for now. But let's remember from yesterday one other program here, and that one was with the circle pattern. All right, yeah, the circle pattern one. Remember when we drew these 48 circles? Ignore the concentric circles. There are 8 on horizontal and 6 on vertical. Well, and we did this exercise using nested loops, right? The easiest way to do this kind of pattern is to use nested loops. And if we remember, let's grab really quick here the notebook and recap that particular part in a second. Just bear with me. Yep, it's over here. We basically divided the entire canvas in a grid of basically we define a constant square size. We say square size is 100, and we played with the numbers, and then we wanted to place these circles inside the squares. So we divided inside this grid that in our case we ended up with 8 columns and 6 rows basically, because square size is 100 and our resolution is 800 by 600 for people new to the stream. All right, so and this of course we did it with I'm gonna switch back here just as a reminder. We did it with 2 nested for loops, which are basically the one that you see on the outside. Ignore the one for the radius that was needed to do the concentric circles, but basically we look to the rows, and for each row we look to the columns and we place the squares. Now, since we are on the lesson about ifs, let's do the same exercise with if statement. So we're gonna do it in only one for loop. So we have a number of circles, which it's, let's start with 48, and let's place these circles in this pattern. All right, really quickly in a single for. So we're gonna look through all the circles this time. I less than n, I plus plus. Refer again to the lesson about the for loops to understand this for loop. So we are about to basically place these circles, and the way we're gonna place these circles is basically in a simple way. We're gonna use this new algorithm. So let's suppose I have here these are my circles. These are square, rectangle sticky notes, but I couldn't find a round one. So we'll start placing them. We'll place 1, we'll place 2, and the notebook is my canvas, right? And we'll place them up until we reach here. And what do we do here? We decide if this one, if the next one, or this one, is outside of the canvas, well, we increase the y coordinate by a certain amount, and we reset the x coordinate to put it back at 0. And we'll do the same until we reach the last one. Of course, the next one, if it goes outside of the canvas here, with this one, it's in the canvas, but the other one, if it's outside of the canvas, we reset it and put it here. So this will be our algorithm. So therefore, we are iterating through the circles only, and let's start doing it. All right, so let's say we place the first circles that we place it at, let's have an x and y coordinates, and the first one, and you know, we'll not do some fancy calculations and adjustments like we did that time with square size. Let's suppose the square size is 100 by 100, therefore that's why we even have 48 circles. And we'll start the x at 50 and y at 50. Why 50? Because we want the circle to be inside the center of the circle, the hotspot of the circle to be inside the first square, which has 100 by 100 coordinates. So we'll start at these coordinates, and what we're gonna do, we're gonna place circles at x and y, and the radius will be 50 here, right? If we do just like that, all the circles will be stacked on top of the other. We have to advance them, put a little bit of a logic here, right? So after we draw a circle, what we can do, we can increment the x by 100. Let's see. Boom! And they just went outside of the canvas. Bye bye circles. Well, now it's time to make that decision. So as you can see, x gets incremented by never stops, right? But we can make a decision. After we increment x, we can check if x is bigger or greater than 800. 800, it means that we reach the end of the canvas on horizontal. So we're gonna make x equal, we jump back at the beginning, which is 50 in our case. And what can we do next? We increase y by 100. We increase the row on vertical. So let's run it again. Boom. The same picture as last time, but only with one single for loop and an if statement here. Now, you know, what if we have more than 48 circles? What if we have 480? Let's put a comment here. Number of circles. What if we have more? Well, if we run it, it basically, we still see 48, but they still get displayed towards the bottom and the bottom here. We don't see them. But however, we can make the program stop. We don't have to loop through all the 480 circles, since we know, however, once they go outside of the screen, we don't see them. So we can also check for y coordinate here. So if y is greater than 600, well, we just break. Nothing else. If we'll run it, should be the same. How can we know that it's running fine? Let's check here if it's greater than 300, which is middle of the screen. Yes, it stops in the middle of the screen. So we're adding circle, 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 circle. And then at this point, y becomes greater than 300. Boom, we stop. So let's put here greater than 600 and it stops. So see, this is another example. So this one is again circles with 1 for. With 1 for and if. The if, it's absolutely mandatory in this case. And if you want to see the other example without basically if, refer to the program from the chat from the yesterday lesson. So circles with 1 for. Okay, the program is on the chat. All right. So let me do a time check here. All right, just a quick, very, very quick exercise, and I'm gonna actually inherit one from yesterday because it's getting late here, but I hope you're gonna like it. Let me locate really quick the one with patterns, which is this one. Let's see if this is the one that I want to locate. All right, yeah, let me locate this one and save a copy. Patterns. I'm gonna name it Commodore patterns. And if is anybody old enough here on this stream to remember the Commodore 64, for the rest of you, I'm gonna show you Commodore 64 print. I think it's print. Yeah, print instruction. Yeah, this one. It was common back in the days for people to print the character slash and backslash in a random fashion, and back then it was a very simple program, and when printed like that, they generated a certain pattern on the screen, right? So I mean these characters here, slash, slash, backslash, slash, backslash. Now the fonts on modern computers, they're more stylish and they don't match nicely, so we cannot do this with characters unless we change to a monospace font, but we'll do it with graphics and with fors and ifs. So that's the purpose of the exercise here. We'll try to achieve that pattern from Commodore with fors and ifs. So basically I inherited the program from yesterday, and inside that program here we are drawing basically, let me remove this rectangle, I think this should be enough. Yep, we are drawing basically 2 lines. Let me put the first line. Let me put back the rectangle. Just for people on the call that didn't see yesterday demonstration. So we are drawing in this grid of squares placed in rows and columns. We are drawing these rectangles, and inside each rectangle we are drawing a line like that. And then the other line, let me comment this one, is in the other direction, and we actually draw them together yesterday. And even we draw a rectangle around them. So what we want to do now is basically to draw either this or the other one. So first one, let's see, the first one, which is the first one? I think is the backslash one. So this is the line backslash, and this one is line slash. So we want to draw either first one or second one in a random fashion. And I'm also introduce you a new function here, how to obtain a random number, how to throw darts. Basically, they are bullseye or not bullseye. They are inside the circle or outside of the circle. And we can take that decision very easily in JavaScript with an if statement and a random number. So a random number, it's totally random. And so basically, before drawing the lines, we have to obtain a random number. So let's say this number is n, and we'll obtain it with a function called random. Just like that, lowercase random. By now, we should be already familiar with this kind of functions, like we saw before sine, we saw square root, and this is the third one that we are seeing, random. So this function, when basically it's invoked, it will return a number. So let's put above a comment here. Random will return a number, a random number, obviously. What a redundant statement. So n random between 0 and 1. So basically decimal number 0.002, 0.052, 0.9991, things like that. I think 0 included and 1 excluded. Anyway, since we have this function and we can obtain a number between 0 and 1, what we can do is very simple. We can check if the number is less than 0.5, maybe draw the first line. Otherwise, draw the second line, because it's like 50-50% chances to be before lower than 0.5 or above 0.5. So let's do that decision here. If n is less than 0.5, basically we are drawing the first line, which is this one. Else, we are drawing the second line here, which is this line. So it's exactly like yesterday patterns, but we are making a small decision there how we draw the pattern based on a random number. So let's run it. Boom! See? It looks like a maze. Amazing maze. Let's vary a little bit here the square size. I think if we make it 25, we'll see more details. Yep. The amazing maze made with fors and ifs in today's coding lesson. And I think this is the last exercise that I want to show you for today. Let me share this one with you. And I hope that you like it. It was a longer lesson, so it was a longer lesson, but nevertheless, I hope that it was useful to you. I leave you with this nice picture here, and basically saying to you, thank you for watching, happy coding, and see you next time.